Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. And a very good day to you who is watching this video, especially my lecturer, Dr. Hafiz bin Muhammad Isa, who lectured me in SCI1033 Physical and Inorganic Chemistry. So today, my name is Muhammad IRFAN bin Muhammad RAZALI with the number metric of 1180857. Will present to you about a topic. Since you have watched my gimmick just now, I think you should have the idea of what I will be presenting today, which is this. You may be right, I will be presenting about bomb, specifically about atomic bomb. So before we go through my presentation, let me put this away first. So, talking about atomic bomb, what is atomic bomb? Is it just a bomb as small as an atom and poof? Well, the name doesn't work that way. So, atomic bomb was defined as a bomb which derives its destructive power from the rapid release of nuclear energy by fission of heavy atomic nuclei, causing damage through heat, blast, and radioactivity. So from this definition, we know that atomic bomb is a massive explosion and a nuclear weapon. So let's go a little bit in the history. So why does history matters? So it is because of we scientists must know how an invention came to the front page of the news. And there is a misunderstanding about this atomic bomb. We always know that Einstein is the one who is responsible of the invention of atomic bomb. But in fact, Albert Einstein never directly making the bomb. He only showed support to the US government in developing this bomb. So the one who we should credit to the invention of this atomic bomb was J. Robert Oppenheimer, which is a physicist from the US also. And the first ever atomic bomb drop was in July 16, 1945 in small town Alamogordo in New Mexico. So this is the first ever atomic bomb was detonated. Okay? And we never forget about the tragedy of Hiroshima and Nagasaki in World War II, which is in August 6 in the same year, the US drops the Little Boy, which is the atomic bomb's code name, in Hiroshima, while 3 days later on 9 of August, the Fat Man, code name also, was dropped in Nagasaki. So this is the picture of the atomic bomb. It's like a torpedo, but it doesn't fly, and it was dropped. So, okay. So we move to the next chapter, how the atomic bomb works. So let's discuss the first ever thing we need to know, which is what material was responsible in this massive explosion. So scientists research and use the biggest radioactive nuclei atom, which can be fissionable and sustainable for this atomic bomb, which is the uranium atom. So let's take a look at the uranium atom. So uranium atom consists of 92 protons plus with 146 neutrons, we will get 238 as its atomic mass. So from this atomic mass, we know that the uranium atom have an isotope. So what is an isotope? So isotope is when we mine the uranium from a whole bunch. There's a slightly part of it was not 238 atomic mass. So it is called as U-235. So this is the one that we want to make the massive explosion of the atomic bomb. So isotope U-235 have the same, since its isotope have the same proton 92, but the different in atomic mass, which is 235. Hence, this isotope only a little part of the whole bunch of uranium, which is only 0.7%, while the other is uranium U-234, which we don't want to discuss today. So we just discuss about U-235, which is we want to know about it. So how did scientists make use of it? Since it was just little, how we can extract those we call it isotopes? So we undergo a process of enrichment of uranium, which is the process of separation of isotopes. Okay, so enrichment of uranium is there are currently two generic commercial methods employed internationally for enrichment, which is gas diffusion and gas centrifuge. So this method, we know that when uranium is turned into gas, it has a property of density, and by density we know that it's corresponding with the mass. Hence, since we know that U-235 and U-238 doesn't have the same atomic mass, we know that U-235 is much lighter since it has 235 atomic mass and much less in density. So we make a filter to separate the gas. So we get the separation of U-235 and also U-238. From that we have the high enriched of uranium U-235. So atomic bomb also apply the principle of nuclear fission. So what is nuclear fission? Nuclear fission is when a radioactive nuclei was slammed by a neutron, it will become an unstable atom. In this case, we have U-235 as the slammed nuclei, and become U-236, which is highly unstable and fissionable or splittable. And then U-236 will split, becoming krypton and also barium, while alongside with those two producing 3 more neutrons. Hence, we also get the energy from it. So, but this is not enough to make a massive high explosion like we already know about the atomic bomb. So we also use the principle of chain reaction, which is in the atomic bomb there is not just one nucleus of uranium, which is more than one. So, but we use one neutron to slam the uranium, since we know that from that fission process, we get 3 more neutron, which this will go to the next and slam the next uranium atom, uranium nucleus. So this is just like a dominoes, if we just push one bricks, and it will follow by the other bricks also. So that's the analogy of it. So hence, since one fission process energy, so a bunch of fission process will produce a bunch of massive energy. Right? So where did this energy come from? So this is how Einstein is responsible for supporting the atomic bomb development, which is this equation. We already know this is Einstein's infamous equation, E equal to mc squared. So E is the energy we can say that the energy produced by the fission process, fission reaction, and the mass is timed by the speed of light squared. So the mass is the after explosion minus with the before explosion, which is the difference of mass in the uranium actually. So we know that C squared is equal to 9 to the power of 10, and 9 times 10 to the power of 16, I'm sorry. It is a massive value. So if the mass is just small, since it was a product with speed squared, it will still have a real massive energy. So let's go through the how are we going to stack them together inside the bomb. So if we have a uranium, we want to put it into a bomb. So how we want to put it into a bomb? So we have to make a vessel which is highly sustainable for the uranium to be put in. So if we put this uranium into a vessel so that it cannot be go out. I'm sorry. Okay. So if we look to the left, the material is too small, and we know that if the new fission process occurs, the neutron will highly spoil the way, which is you will get out from this vessel. And if we increase the mass, it just increase the self-sustaining, but the neutron will not keep inside the vessel. So we use what we call as temper, which is a neutron reflector, to make the neutron bounce back like this, bounce back. So the neutron will be the process will be self-sustaining. Hence, will be a maximum value of a fission process will occur. So subcritical mass. So if we want to make like just now is supercritical mass, which is the vessel, which if we just make that vessel, we will be exploded by it as well. So we need to separate both the supercritical mass into a subcritical mass. So as we can see, it has two parts, where the first part, the left one, will be detonated and then will be slammed into the second part. So it is just like this. Imagine this is the subcritical mass, and also this is the subcritical mass also. And then if the detonator was triggered, it will be slammed and become the supercritical mass. Hence, the explosion will occur. So that's how they make the atomic bomb. So this we can see the fat man and also the little boy, both using the same principle, which is they use subcritical mass. Okay, so what is the power? How power is it? We never see it, we never saw it, but we always know, we always heard about power. Okay, the Hiroshima bomb, let's take a look. The material used was uranium-235, which is 235. It is believed that the fission of slightly less than 1 kilogram, which is 0.6 gram of uranium, released energy to approximately 15 kilotons of TNT. So this is why scientists want to use the uranium atom, because just the difference of mass is 0.6 gram. 0.6 gram, which is just 600 milligram, will be 15 kilotons of TNT. That is subhanallah, so massive. And the Nagasaki bomb, so we compare it to the plutonium-239, which is Nagasaki bomb, which is the fragment used of plutonium-239. So the fission process occur with 1 kilogram of plutonium have released the destructive energy equivalent to about 21 kilotons. So we can see the difference in energy produced. For 0.6 gram, we have 15 kilotons of uranium. For plutonium, we have more than 1 kilogram, but it's also high, but it is required more mass, more plutonium in order to make a massive explosion. So that's why uranium is being used. The effect of atomic bomb. So what is the effect? We want to see the effect of atomic bomb to the world, which is to the victim, I guess, and also to the one who created it. Because we know that if one scientist created a invention, a theory, sometimes they will have their own pride. We want to what we call that as their pride. Right. Alright. So what atomic bomb bring us is death, of course. From the incident of Hiroshima and Nagasaki, we have 146 people and 39. I'm sorry. In Hiroshima is about 90 to 146,000 people died, while Nagasaki 39 to 80,000 people died. And a large number of people continue to die for months afterward from the effect of burns, radiation sickness, and other injuries, compound illness, and nutrition. So instead of what we call that death, so the one who didn't die at that exact time also had the effect on them, which is illness, and then prone to die also. So, and then we know that the massive explosion will bring the destruction. So destruction, destroying a city. So that is very dangerous. So let's take a look about to the effect on the inventor. So they regret actually. So when Oppenheimer tested the first ever atomic bomb, he said, he quoted from the Hindu scripture, which is Bhagavad Gita. He said that now I am become death, the destroyer of worlds. Instead of that, Albert Einstein also feel the same way. He said that had I known the Germans would not succeed in producing an atomic bomb, I would have never lifted a finger. So we can see that both of the inventor, which is the first Oppenheimer was the inventor, and Albert Einstein was the one who initiated the EMC square, both regret the invention of the atomic bomb. So let's take a look about the Islamic view on this issue. So this is taken from the Holy Quran, Surah Al-Ma'idah, verse 32. We can see here. So, and also from the Hadith Nabi Sallallahu Alaihi Wasallam, translated, surely the most despicable are those who attack anyone who does not attack them, one who kills those who do not fight them. So we know that the purpose of atomic bomb created was to war, to bring fear also. So in Islam, we have all encountered many war in the time of Prophet Muhammad sallallahu alaihi wasallam, But Islam doesn't have their own rule in the war, which is we cannot kill those who are not involved in the war. We cannot kill plant, we cannot kill children, we cannot destroy plants. But when we take a look of atomic bomb in war, it destroys everything. Even for the civilians, was killed, was murdered. So Islam has its own stand that the creation and usage of atomic bomb in war or in anything else, which is haram, is haram. But learning is quite important because nuclear also can be used to generate electricity. So we use the dangerous thing to become a benefit. So that is allowed in Islam. So I think that's all from me. Thank you for your hearing. I think that's all. Assalamualaikum warahmatullahi wabarakatuh.